Welcome. Today we are going to see distance in graphs. Let's see about the definition of peripheral vertex. A vertex B in a connected graph G is called a peripheral vertex if E of V is equal to diameter of G. Let's go for another definition, periphery. The subgraph of G induced by its peripheral vertices is the periphery and it is denoted by PER of G. Let's have an example. You could see the figure. Here in the graph H, we have the eccentricities like 2, 3, and 4. Of course, radius of H is equal to 2 and diameter of H is equal to 4. You could see the two vertices W and V. It has been darkened. Now in this example, if we have calculated periphery of H, so this is the subgraph induced, W and V. So W and V are the peripheral vertices of H. Of course, the graph is disconnected. Let's go for another example. The graph F. Here we could observe the eccentricities 2 and 3. So the minimum eccentricity, that is radius of F, is equal to 2 and diameter of F, which is the maximum eccentricity, is 3. So if we calculate the periphery of F, if we draw it, we have the cycle C6. Let's see an interesting theorem. A non-trivial graph G is the periphery of some graph if and only if every vertex of G has eccentricity 1 or no vertex of G has eccentricity 1. Let's move to the proof. Assume first that every vertex of G has eccentricity 1 or no vertex of G has eccentricity 1. If every vertex of G has eccentricity 1, then of course G is a complete graph and so periphery of G is equal to G itself. Now assume that no vertex of G has eccentricity 1. This implies that for every vertex U of G, there is a vertex V in G that is not adjacent to U. Let H be the graph obtained by adding a new vertex W and joining W to every vertex of G. Then eccentricity of W in H is equal to 1. Since eccentricity of X is equal to 2 for every vertex X of G, it follows that every vertex of G is a peripheral vertex of H. And so, periphery of H is equal to G. Let's go for the converse part. Let G be a graph that contains some vertices of eccentricity 1 and some vertices whose eccentricity is not 1. Assume to the contrary that there exists a graph H such that periphery of H is equal to G. G is a proper induced subgraph of H. Then there exists an integer k greater than or equal to 2 such that eccentricity of V is equal to k for every vertex V of H, while eccentricity of V less than k for every vertex V of H that is not in G. Let X be a vertex of G such that eccentricity of X in G is equal to 1. Let W be a vertex of H such that the distance between X and W, that is equal to eccentricity of X, which is equal to K, greater than or equal to 2. Since W is not adjacent to X, it follows that W is not in G. However, distance between W and X is equal to K, and so eccentricity of W in H is greater than or equal to K, contradicting the fact that W is not in the periphery of H. Let's go for the next definition, eccentric vertex. For a given vertex U in a connected graph G, there is a vertex V such that the distance between U and V is equal to E of V. That is, V is a vertex that is farthest from U. Such a vertex V is called an eccentric vertex of U. A vertex V is an eccentric vertex of the graph G if V is an eccentric vertex of some vertex of G. Let's see the example. You could see the figure here. Eccentric graph. A connected graph G is an eccentric graph if every vertex of G is an eccentric vertex. So this is the figure. You can see an example here. Here every vertex of G is an eccentric vertex. Eccentric subgraph. Let G be a connected graph. The eccentric subgraph of G is a subgraph of G induced by the set of eccentric vertices of G. So you could see the graph F. Of course, the eccentric subgraph denoted by ECC of G. Sorry, here F. Let's move to a theorem. A non-trivial graph G is eccentric subgraph of some graph if and only if every vertex of G has eccentricity 1 or no vertex of G has eccentricity 1. Let G be a non-trivial graph. Assume every vertex of G has eccentricity 1 or no vertex of G has eccentricity 1. To prove that a non-trivial graph G is the eccentric subgraph of some graph, if every vertex of G has eccentricity 1, then G is complete and G is an eccentric graph. Thus, eccentric subgraph of G is equal to G. Next, assume that no vertex of G has eccentricity 1. Let H be a graph obtained by adding a new vertex W and joining W to every vertex of G. Since every vertex B in H that belongs to G is an eccentric vertex of W, but W is not an eccentric vertex of any vertex of H, it follows that ECC of H is equal to G. Hence, a non-trivial graph G is the eccentric subgraph of some graph. Let's go for the converse part. Assume that a non-trivial graph G is the eccentric subgraph of some graph. Let G be a graph such that some but not all of its vertex have eccentricity 1. Then G is connected. Assume to the contrary that there exists a connected graph H such that ECG of H is equal to G. Let U be a vertex of G that is adjacent to all other vertices of G. Let B be an eccentric vertex of U in H. Since all eccentric vertices of H belongs to G, it follows that B is in G. However, B is adjacent to U, so eccentricity of U is equal to 1. U is adjacent to all other vertices in H, and that all vertices of H that are not in G also belongs to ECG of H. This is a contradiction. Hence, every vertex of G has eccentricity 1 or no vertex of G has eccentricity 1. Thank you. Of G. Let B be an eccentric vertex of U in H. Since all eccentric vertices of H belongs to G, it follows that B is in G. However, B is adjacent to U, so eccentricity of U is equal to 1. U is adjacent to all other vertices in H, and that all vertices of H that are not in G also belongs to ECG of H. This is a contradiction. Hence, every vertex of G has eccentricity 1 or no vertex of G has eccentricity 1. Thank you. Of G. Let B be an eccentric vertex of U in H. Since all eccentric vertices of H belongs to G, it follows that B is in G. However, B is adjacent to U, so eccentricity of U is equal to 1. U is adjacent to all other vertices in H, and that all vertices of H that are not in G also belongs to ECG of H. This is a contradiction. Hence, every vertex of G has eccentricity 1 or no vertex of G has eccentricity 1. Thank you.